Good morning, students. Yes, electrostatics. Some questions for preparation of Neet and delivery. First question: a charged particle Q is shot towards another charged particle Q, which is fixed. Its speed v. It approaches Q up to a closest distance r and then returns. If Q were given a speed 2v, then closest distance of approach is 1. Now, what is closest distance of approach? See, here it is. If we have this charge Q, which is moving with velocity v towards another charge Q, which is stationary, which is fixed. Okay? So yes, as it is shot towards another particle, Q is positive charge, capital Q is also positive charge, so there is repulsive force between them. So as this particle which is shot towards this fixed charge is shot towards it, as it is moving towards it, its kinetic energy decreases due to force of repulsion between them. Okay, yes, due to force of repulsion between them, kinetic energy decreases. So yes, its kinetic energy decreases, and at some distance, its total kinetic energy will become zero. Its total kinetic energy will become zero. You know that according to law of conservation of energy, its kinetic energy decreases, potential energy increases. Potential energy increases. So as it approaches to this distance, it is called closest distance of approach, that is r. Okay, what is closest distance of approach? The distance, the minimum distance up to which this charge can move. This charge can move. So yes, this charge is approaching towards this fixed charge. Its kinetic energy decreases. At this point, its kinetic energy becomes zero, but its potential energy becomes maximum. So we can say its total kinetic energy is converted in potential energy at distance of closest approach. At distance of closest approach, its kinetic energy, that is half mv square, is equal to its potential energy, that is, what is equation of potential energy? Yes, it is K Q1 Q2 upon R. Okay, so now make R as subject. So what is the equation of R? R is equal to, if you make R as subject, it is 2 Q upon mv square. Simple. 2 constant, K medium between two charges constant, Q charge constant, capital Q constant, M constant. What is change? If Q were given a speed 2v, means only speed is changed. Only speed is changed. So yes, here 2K Q M is constant. So here I can write R is proportional to V square. It is R is proportional to, R is proportional to, it is 1 upon V square. Simple. So yes, how to find? It is R2 upon R1 is equal to, it is V1 upon V2 whole square. So R2 is equal to V1. What is V1? Yes, it is V. What is V2? It is yes to V, its whole square, and here it is R1, means it is R. So we got 1 upon 2 square, means it is R by 4. Means it is R by, simple. So yes, it is one concept, a distance of closest approach. At distance of closest approach, the total kinetic energy is converted in potential energy. Okay. Now next question. See next question. You are given 4 capacitors C1, C2, C3 and C4 connected this voltage V. C1 is equal to C, C2 is equal to 2C, C3 is equal to 3C and C4 is equal to 4C. You have to find ratio of charges on C2 and C4. You have to find ratio of charges on C2 and C4. Yes, here it is C2 and here it is C4. You have to find ratio of charges on them. Okay? See, here, from figure it is clear. C1, C2 and C3, they are connected in series connection. Yes or no? Yes, they are connected in series connection. So I can draw one equivalent figure like this. Okay, that it is C4 and it is its equivalent C dash. Simple? है ना? Okay, yes. C1, C2 and C3 they are in series connection. Their equivalent is C dash and it is C4. So see, with this battery, this C4 and C dash they are in parallel connection, and in parallel connection, potential difference remains the same. So charge on C4, that is Q4 is equal to what is equation of charge? C is equal to Q upon V, so Q is equal to CV. It is C4 into V. What is value of C4? It is 4 CV. That is equation number 1. Now yes, we got charge on C4. We have to now find charge on C2. How to find charge on C2? Yes, how to find? So first of all, I have to find this equivalent capacitance C dash. How to find this equivalent capacitance C dash? See, here it is. The C1, C2 and C3, they are in series connection. So what is equivalent of this series connection? I have assumed it is C dash. Then how to find C dash? See, 1 upon C dash is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So 1 upon C dash is equal to this 1 upon C plus 1 upon 2C plus 1 upon 3C. If I am taking LCM 6C, then here it will be, yes, it is 6. Plus here it will be 3. Plus here it will be 2. So yes, it is 6 plus 3 plus 2. It is 11 by 6C. So therefore C dash is equal to, it is 6C divided by 11. It is 6C divided by 11. Clear about this? So yes, C dash is equal to, it is 6C divided by 11. Any doubt? Okay. Now it is C dash. Charge on this. Okay. Capacitance of this. Now what is charge on C dash? Okay, charge on C dash. That is Q dash is equal to C dash into V, because they both are in parallel connection with battery. So what is value of C dash? It is 6C upon 11. Here it is into V. Simple? Yes, it is simple. Now C dash. What is C dash? C dash is series connection of C1, C2 and C3, and we know that in series connection charge remains the same. So as C dash is series equivalent of C1, C2 and C3. Q1 is equal to Q2 is equal to Q3 is equal to Q dash. Yes, you know this, okay? In series connection charge remains same, and it is 6C divided by 11V. Simple. So now what is charge on second capacitor? It is Q2. So charge on second capacitor Q2 upon charge on fourth capacitor Q4. What is value of Q2? It is 6CV divided by 11. What is Q4? Yes, it is, here it is 4C. So here it is 4C. So CV cut is equal to, here it is 3 into 2 and here it is 2 into 2. Clear? So yes, it is 3 divided by 22. Here it is 3 divided by 22. So yes, your answer is 3 divided by 22. Okay, if you are given these 4 capacitors, then how to find charge on ratio of charge on 2 capacitors? It is 3 divided by 20. Clear? Yes. See, next question. 3 point charges plus Q, minus 2Q and plus Q are placed at points 0, A0, 0, 0, 0 and A0, 0 respectively. The magnitude and direction of electric dipole moment vector is. See, first one is at 0, A0, second one is at 0, 0, 0 and third one is A0. Means they are like this. If I draw figure, it is x-axis, y-axis. It is origin. First is at 0a0. 0a0 means it is on y-axis at distance a. So first charge is here, that is plus q here. Distance is a. Second, minus 2q charge. It is at 0, 0, 0 means here it is at origin. Minus 2q. Okay. And third one is at a00 means on x-axis at this distance. It is a00. Okay. Yes, this distance is a and this charge is plus 2. So you have to find what is the magnitude and direction of electric dipole moment. So yes, as you are given three charges, plus q, minus 2q and plus q, but you are given two electric dipoles. Yes, I can divide this minus 2q charge in minus q and minus q. So yes, one dipole, I can write this minus q charge as, I can write this minus 2q charge as minus q and minus q. So one dipole is between plus q and minus q, another dipole is between minus q and plus q. Its dipole moment, it is from minus to plus, means in this direction. It is its dipole moment. Yes or no? Dipole moment P. And its dipole moment, it is in this direction. Let it is P1 and let it is P2. Simple. And we know that magnitudes of P1 and P2 are same. P1 is equal to P2 is equal to Q. And what is distance between two charges? Yes. Plus Q minus Q, distance between them is A. Distance between them is A. Simple. So yes, the magnitudes are equal, but the direction is, see that direction perpendicular to each other. So you have to find what is resultant dipole moment. Yes, resultant dipole moment. Resultant dipole moment. P is equal to, it is P1 plus P2. Now how to find its magnitude? Yes, first of all we will find its magnitude with the help of law of parallelogram. That is its magnitude. P is equal to, it is under root P1 square plus P2 square plus 2 P1 P2. And what is angle between them? 90. So yes, it is cos 90. And cos 90 will be 0. So it is P is equal to under root P square plus P square. So this P is equal to root 2P, means it is root 2 into P. So yes, it is its magnitude. Now what is direction? Yes, according to law of parallelogram, if I complete parallelogram, okay, then resultant vector means resultant dipole moment, it is in this direction. It is in this direction. Simple? Yes or no? It makes exactly 45 degree with this x-axis. Or we can say it is on line joining 0, 0, 0, and this one will see x component A, y component is A. So its direction, how to write its direction, okay, along line joining 0, 0, 0 and A0. Simple. A0 means in this direction. So yes, you have to find this magnitude and direction. Simple. So yes, if you are given charges like this and you have to find resultant dipole, then you have to identify numbers of dipole with that direction. Okay. Now we will see another question which is based on electric dipole. See, here it is. Two electric dipoles of moment P and 64P are placed in opposite direction on a line at distance of 25 cm. The electric field will be 0 at a point between the two dipoles at distance blind from dipole moment P. What is question? See, first of all, let it is one line. Okay, two electric dipoles of moment P. Let it is first electric dipole having dipole moment P. It is in this direction. Okay, and 64P, they are placed opposite. So yes, it is in opposite direction. And its dipole moment it is P, and here it is 64P. What is distance between them? This distance between them is, suppose it is center. Distance between them, it is 25 centimeter. Yes, it is 25 centimeter. Between their centers, okay, between their centers. So your question is, the electric field will be 0 at a point between the dipoles at distance blank from dipole moment P. So yes, from this dipole, I am assuming at this point, not exactly at the midpoint, because these two dipoles having different magnitude. Okay, so yes, at this point, at point A for assume, sir, okay, at point A, let total electric field is 0. Let at point A, electric field is 0. Now electric field is 0. Why electric field is 0? Because see, on axis, this point is on axis of first dipole, this point is on axis of second dipole. So yes, on axis we know that electric field is in direction of dipole moment. Yes, it is. So due to this, at this point electric field E1, it is in this direction. Due to this electric field E2, it is in this direction. They both are having opposite direction, and if their magnitudes are same, then and then the resultant field will become 0. Okay, so yes, E1 is equal to it is E2. E1 is equal to it is E2. Okay, direction opposite. If their magnitudes are same, then it becomes 0. Now, yes, we will consider these two dipoles short dipole. And for short dipole, we know equation. What is equation? Yes, it is 1 upon 4 pi epsilon 0. On axis, it is 2 dipole moment P upon what is distance? Yes, I am assuming this distance x. So it is x cube. Yes or no? Yes, it is. 1 upon 4 pi epsilon 0, 2p upon r cube is equal to this side. It is 1 upon 4 pi epsilon 0. 2 is in equation and its dipole moment is this 64p. It is 64p divided by. Now, if distance of this point A from this T is x, then what is distance from 64p? Obviously, this distance it is 25 minus x. So yes, this distance it is 25 minus x. Okay, so see, this 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0, 2p cut. Yes, it is. So if I am taking this 25 minus x this side, then I can write 25 minus x upon x whole cube is equal to 64. Is equal to 64. Now if I am taking cube root both sides, then it is 25 minus x upon x is equal to what is cube root of 64? Yes, it is 4. Yes, it is 4. Then yes, it is 4. Now I am multiplying for this side. So 25 minus x is equal to it is 4x. 25 is equal to it is 5x. So x is equal to it is 5. Distances are, yes, they are in centimeter. Yes. So it is 5 centimeter. So at distance 5 centimeter from this dipole, resultant electric field will be 0. Clear? Yes, you have to remember equation and what is direction. What is direction of electric field? On axis, direction of electric field is in the direction of dipole moment. While on equator, direction of electric field is in opposite direction of electric dipole moment. Clear? So yes, I think it is easy question. Okay. Okay, see, next question is, yes, in the given circuit, if point C is connected to earth and a potential of plus 2000 volt is given to A, the potential at point B is AC. Okay, first of all, we will simplify this circuit. See, 10 and 10, they are in series, so their equivalent is 5 microfarad. 5 microfarad and 10 microfarad. They are, yes, they are in parallel connection. So their equivalent will become 15. So if I want to draw another figure, I can draw like this. See, here it is. It is at point A. It is at 2000 volt. It is point B, and here it is point C at B is equal to 0. Okay, its capacitance is 5 microfarad and its capacitance is 15 microfarad. Okay. Now see, these two capacitors are in series connection, and in series connection charge is same. In series connection, charge is same. Okay, so yes, potential difference between these two ends. Okay, if it is at 2000 volt and it is at 0 volt, so what is potential difference between them? Yes, I can write potential difference between them as 2000 volt. Okay, now if potential difference between two ends of first capacitor is V1, potential difference between two ends of second capacitor is V2, as charge is same, we know one equation, that is C is equal to Q upon V, or V is equal to it is Q upon C. So V and C, they are inversely proportional to each other. Yes or no? So if here it is 5 and it is 15, so its capacitance is 3 times. Yes or no? Capacitance of this capacitor is 3 times. So potential, if I am assuming V1 is equal to it is V, then V2 is equal to it will be V by 3. Why V by 3? Because V and C, they are inversely proportional to each other. Yes or no? So yes, V1 plus V2. Obviously it is 2000 volt for series connection. What is V1? I have assumed V. What is V2? I have assumed V by 3 is equal to it is 2000. So yes, it is 4V by 3 is equal to it is 2000. Simple? Yes, it is simple. So V is equal to it is 2000 into 3 divided by it is 4. 4 into 5. 5 into 3 is 15. So V is equal to it is 1500 volt. Now V is potential difference between these two ends, between A and B. Hello, listen. V1, I can write V1 as it is, yes, it is 1500 volt. But V1 means potential difference between A and B. So I can write it as VA minus VB is equal to 1500. What is VA? 2000. If I am taking 1500 this side and it is equal to VB, then what is value of VB? Yes, value of VB is 500 volt. Value of VB is 500 volt. So it is how to solve a question, okay, in short time with short method. Clear about this? Yes or no? Yes. You have to remember this relation. Okay. Here it is C1 is equal to C and C2 is equal to 3C. And as they are in series connection, charge is same. So V and C, they are inversely proportional to. So capacitance becomes 3 times. The potential difference becomes, yes, becomes 1 upon 3 times. So with the help of that relation, you can easily find V and then put in this value, you will get your answer. Okay.